Now, I will show how to implement the QSUM and the EWMA control charts as time-weighted control charts by using Minitab statistical software. For this purpose, let's reconsider the generated data, where we generated the 20 observations, the first 20 observations from a normal distribution with mean 10 and standard deviation 1, and the remaining 10 observations from a process where the mean has shifted to 11 and the standard deviation remained the same at the level 1. To implement the QSUM control chart, let's go to control charts again from the start menu. This time we select the time-weighted charts. We select the QSUM here. The data is already provided here as 2 columns. The data is for individual observations, so we have the period in 1 column and the individual observations in the second column. We have 30 observations in this example. Again, the first 20 come from a normal distribution with mean 10 and standard deviation 1. And the last 10 observations, 21 to 30, come from a process where the observations are again normally distributed, but this time with mean 11 and standard deviation again 1. So here we need to define which variables we will use. I will select xi, and here all observations for a chart are in 1 column. Option is selected because we have 1 column for the observations. I will enter the subgroup size. Subgroup size is 1. I will assume that the QSUM is used in phase 2. Therefore, we don't need to do any estimation. We have a given target value, which is 10. So I will enter here 10 as the target value. Now let's go to QSUM options. As we assume the parameters are given, we know that in control standard deviation is 1, so I will enter the parameter value. I will not estimate anything because the QSUM and EWMA control charts are generally used in phase 2 for process monitoring. We generally prefer shift-R type control charts for process parameter estimation. Now, we will not do any estimation. We have different plans types for the QSUM. I will consider the one-sided QSUM. I will not consider the VMAS QSUM. If you prefer, you can use the fast initial response feature here. For the QSUM plan, let's consider H to be 5 as given in the example in our textbook. I will not define any stages here because we have only the monitoring stage. I will not consider any boxcast transformation because I will assume that the observations are normally distributed. For the display, I will leave it as the default. I will not have anything to be stored. But if you prefer, you can tick these to be stored in the worksheet. So let me click OK. Once again, click OK. And we have the QSUM control chart as in our look. The upper control limit is 5, the lower control limit is -5. And we have observations 29 and 30 signaling a change in the process mean. The same data set can also be studied by the time-weighted control chart, the EWMA control chart. Again, we go to Start. These are control charts, time-weighted charts. This time EWMA. We need to define the observations. So all observations for a chart are again in 1 column. So I select XI or the column C2. Subgroup sizes is 1. We can define different smoothing values or weights for the EWMA chart. By default, it's given as 0.2. Let's make it 0.1. And here we have the EWMA options. Again, I will assume that the parameters are known. So the mean is 10. Standard deviation is 1. I will not do any estimation as in here. S limits. Yeah, this time in standard shift-R type control charts, we use 3 sigma control limits, but let's use it the 2.7 standard deviation limits for the EWMA control chart based on our design. By default, this is 3, but I set it as 2.7, so we will have the control limits at 2.7 standard deviations. Tests, by default, we have a test where 1 point exceeds 3 sigma limits is a signal, so let's make it 2.7 to be consistent with the control limits that we determined. Stages, I will not consider any stages here. This is a phase 2 study. Box-Cox transformation, I will not consider the normality of the observations. I assume that the observations are normally distributed. I will not make any changes in the display, and the storage will be the same. So let's click OK, and let's click OK here. And we have the EWMA control chart. And again, the control chart indicates an auto control at the sample 29. So we use 2 time-weighted control charts. We assume that the observations are normal distributed. Let me illustrate the check for normality to test the goodness of the normal distribution. We need to go to Start. We need to go to Quality Tools. You need to select the individual distribution identification here. The data are in a single column, which is C2. Let's specify the distribution that we would like to test. So I will use only the normal distribution, and I will untick the other ones. So the normal distribution, I click OK. And as you can see, the data is approximately normal distributed. Now we have a p-value again greater than a significance value of 0.05. So with a significance with a p-value of about 0.5, we can consider that the normal distribution is suitable for this data. Of course, as a time-weighted control chart, one can also consider the, let me show that, other chart, the moving average control chart, where we have the option here. I did not consider this, but we can also have it done simply by selecting the data. You can define the subgroup sizes. In our example, subgroup size is again 1. Length of moving average or the window size is, let's say, 3. In this example, I will leave it like this, and I will simply click OK. And here we have the moving average control chart. Okay.